Hi, good evening everyone, and welcome to the 11th session of School of AR. Today we'll be learning about very interesting advanced capability that is hand tracking. And we have Naveen with us, our expert trainer, who will be teaching you how to create your AR effects using hand tracking. Over to you, Naveen.
Thanks, Adkar. Very good evening, everyone. I hope you're doing well and been having a fantastic week and already looking forward to the weekend. So today's session is our 11th session, and we have reached to the hand tracking, which is another simple capability, just like a face tracker. It gives you coordinates of your hands, and using those coordinates, you could create some children objects like a 3D object, like a 2D object inside the hand tracker, and then those objects will follow the movement of the hand. So we're going to start in a while. Hi, Chintan. Very good evening. Praveen, Sahil, hi, Devansh. I've looked into your assignments. A job very well done. A lot of you have now a better understanding of how the pulses work, how the patches work, how to combine the capabilities. So yeah, pretty well job done. I'm looking forward to the second assignment now, but I want you to make a little more complex filters now. Like, give your best, give some time to it, and try to figure out how can you be more creative, because now you understand the functionality. So why not build on it now? And um, I think you must have already got. Asghar, have they gotten already the assignment? Okay, so you've gotten the second assignment, and if you have any questions regarding that, you can feel free to ask about them today.
There's one question from Shekhar. I put it
Yep.
on the screen.
I can't figure out how to make overlay for light background as asked in assignments. Any hints? Sure. Let me teach you that. No worries. It's a very simple thing though. I think all you have to do is use a rectangle and reduce its opacity. But the tricky part is that should not affect other things like 3D models. So okay, we can talk about this right now. I'm gonna share the screen and address Shikhar's question. So bear with me for a moment. All right, Shekhar, this is for you. So what you do, I'm doing is I'm creating an example for you. So you have to take the learnings from the example and apply it yourself, because I'm not going to tell you how to do the exact thing. So I'm going to just create a blank project just to explain this thing. And also I'm going to import a 3D object, which is maybe something that I recently used. Um, Rugby ball, propeller hat. Not sure what kind of rugby ball is this. Let's go with it. And meanwhile, that downloads, I'm gonna create a canvas. This canvas is going to hold a rectangle, which is I'm gonna put 100% on the width and 100% of the height, which is covering my entire screen right now. I'm gonna assign a material to it so that I can control its opacity and give it a color. Shader type, I set to the flat, and color, I'm choosing a very random color out of my library, maybe yellow, and I'm gonna just set down its opacity to like quite a bit. So this is called an overlay. That my camera texture is behind it right now. Like whatever my camera sees is behind it. So this is overlaid. But let's say, for an example, now you have a another thing in the ball, like a rugby ball. So if this ball is um, it's not quite visible because the color is the same, so I'm gonna just go and make it like a blue. So right now this rugby ball is actually in front of the rectangle, so it's not overlaid by it. But has it been like a different structure, or this ball is maybe behind this rectangle, then probably the color will be overlaid, like because of the z depth of it. All right. but how to make sure that it doesn't ever affect my these objects. So what I'm going to do is I'm not going to care about what kind of render order is this, like bottom to top it is right now. First the canvas loads and then the rugby ball loads, but because of the 3D position of the ball, it kind of is safe now from the overlay, but if it is back, it's not safe from the overlay. So to avoid all these things, like positioning and everything, because I don't want this overlay to my 3D object any white, so I don't want to care about it. So what I'm going to do is I'm going to create a custom render pipeline. So how you do this is you go to device, and either you can just click on create. I like to do things from scratch every time I do it, so it becomes like a practice, a good practice. So what I'm going to do is I'm going to just create an render pass here. So right now there is no signal to my device. I click on my device, create a render pass. Since right now there's no signal to it, it's going to show you a blue screen. So what I want to show is I want to show the rugby ball. Okay, so I create a patch for it, a producer patch for it. This is a producer patch. This is a consumer patch. Producer patch because it gives something out. Consumer patch because it consumes the data. All right. So I'm gonna take this rugby ball, and if I just give it to a scene render pass right now as a scene object. So uh, in the preview, it will show me that only the ball, because custom pipelines, the usage of custom pipeline is that I don't want to worry about anything else but just the object that I want to render. So right now, if I just want to render the ball, it's just going to show me the ball. Okay, nothing else, like no camera texture, nothing. There's nothing here. Black color because of the background color is black, so I'm going to just make it transparent. So now you're just going to see a gray texture. And so now this is my ball, my basketball. So I'm gonna use now this canvas also. We also want the canvas. So to do that, what I'm gonna do is I'm gonna create another scene render pass for this. Give it a scene object, and I can see that canvas I can see in here. All right. So that's okay, but this has to go somewhere else. So what if I can give a background to this guy? I can also give a background to this. Right now, its background is black. I'm gonna make it transparent also. And this whatever output comes to me, if I directly give it to the device, then all I'm gonna see is this rectangle, nothing else. But I want to see both the things. So what I'm going to do is I'm not going to give it to this. I will give it to the background of this render pass. So earlier I was just able to see the ball. Now I have the background in behind the ball. Now no matter where this ball goes, in the Z or in the Y or X, wherever, this thing is always going to be in the background. So I don't have to worry about the render order, like how they are placed. Whatever the order is, the new order follows this: first the canvas, and then the ball, and then it goes to my device. So now I see that it will never, like, if I no matter how much I move this ball, wherever I go, it's never gonna be under my overlay. Now we're missing the camera texture, so the camera texture could be directly just given to this guy. So first I need the camera texture, so go to the camera texture extraction, take this out and give this as a background in here. So now you can see that everything else is overlaid with the color, all right, but this ball is not. Okay, and this would never be, but my camera texture would always be overlaid. Okay, just gonna make it a little small, like maybe 0.5, 0.5, and 0.5, and change the color to maybe something else, some other overlay that you like, whatever. This is not gonna affect our ball. Okay, so yeah, I hope that is clear. Is that clear, Shaker? um, Feel free to choose a opacity of this guy, whatever you want to do. And other methods to explore overlaying is that there's a blend patch in here. So we've used this earlier also. Whenever you're combining two textures, it's very useful. The source is the texture which is going to come at the top, and destination is the texture which is come at the background. All right. So right now, if I have to blend it, the way this has been shown here, the source is my ball and destination is my overlay background because that has to be in the bottom. Yeah, Shaker, you could do this. The gradient, take this color out, make this super white, so we don't have to worry about like because we're gonna custom give this. And there's a gradient patch we have. It creates a horizontal, circular, or like a couple of types of gradient. If you directly give this to this guy, it's just gonna create a gradient, like. But if you use a gradient step has a couple of inputs that you can give. So it's first what kind of gradient you want to have. So this is my horizontal gradient that I want to have. And my previous step, like let's mix two colors. So this is this is 0 and this is 1. If I use it directly the output, then what it's gonna work is black, because previous step is 0. So start from black. When it is super black, it is transparent, so I can see the behind of the camera texture, super transparent. Okay. And when I'm going towards zero point 0.5, this is zero point 0.5, the black has finished. Okay, so started finishing. So and then the white has started shaping up. So this is super white. So we can control this. We can have a different color in here, like a and different color in here like this. And maybe start range to be, let's say, 0, but end is 0.33. So it's gonna be less in here but more in the last part. You can create multicolor gradients also. So what you're gonna do is just copy paste it again. And now this gradient can go in here, this output can come in here. And this we can choose a different color now. And this also we can choose a different color. And since we have covered from 0 to 0.33, let's start 0.33 and go up to 0.66. So now we have like 4 color gradients. And then you can have one more, go for 0.66 to 1, and then you can like cover the entire like that. You could also change this like a vertical, like a circular as well. And then if you want a custom angle, that is your homework to figure out. Although like use like a 2D transform pack for that, and you can also rotate it. How can we do this with multiple 3D object? Shekhar, I would like you to be a little bit specific with your question. What is this we're doing with the 3D multiple object? How can we do this with 3D multiple objects? Should I just pass the null object that contains all the objects as null object to this scene render pass? Yeah, I mean, yeah, of course, that's right. You know it already. So null object is like a combination, is a holder for like a lot of things. So if I have a null object, okay, and if I put everything inside, even my 3D model or even my canvas inside this, I can just do this like this to render both. But again, if I do like that, my purpose is not solving. My purpose is that I don't want to worry about the render order of these things. If I put it like this as a 1, then the render order will be considered, right? Because inside that children there has to be a hierarchy. So we made that hierarchy by doing it with the individual objects. But in this case of the assignment, let's say you have multiple 3D objects. So what you're going to do is don't put the canvas inside, and this null object could be that guy in here. Instead of the rugby ball, I'll just put this null object in here. Okay, and then that you can put all the 3D objects into it, and then your purpose is solved. Yeah. So, all right. Kunal says that I'm having file size issues when trying to create the AI filter. Is it fine with one object, but I am not able to do the with 3 object? Okay, so okay, you're having issues. Let's try to find a solution. I would not say that just do it with one object, because the assignment is to give you awareness of how things work. So I want you to work with like multiple objects first, and then see, you can show your filter differently. Like let's say when the filter opens, it's just one character that you want to work with, but there are options to change to the other characters. Okay, so we want that in the assignment. And to answer your question, well, you can use some methods. Try to find low poly objects, like when you search in the library, maybe try to find some low poly objects. Low poly objects, they have less geometry. So let me show you. Go to the AR library, and let's say let's say my model is Superman, or like a Superman character. I want Superman character, and I see that there are like plenty of characters in here. If I go to like Sketchfab and also want animation in it, so there are like couple of left. Now I see that maybe this guy is like super detailed, like it's gonna be very big, but it's not. It's super small. It's only like 5636 geometry, so its file size is very less. However, its texture might be very big. So for that, we have to take care of those textures. So let me take you one example and solve you that. But let's go through other models. This guy looks pretty. Yeah, its geometry is even larger than that. It doesn't have textures also. So let's take this guy. I think it's a good model. Very less geometry, only 5636. Maximum you can have is for one object is 50K. 50K polygons is the maximum. Triangles is the maximum you can have. And if you're having multiple such objects, then 150K is the maximum limit to that. So you have to be in the limit for that. Okay. So I'm going to import this guy and see if we can change its textures. So right now my project was very small. I think we just added to. I think the file size of this was very less. I think this is compressing. So my textures are like 5 MB. My textures are so like how to access the asset summary. You can go in here and show patch editor to the patch editor, show for asset summary, and you can see that the asset summary, like what texture you have, how much is the size they're occupying. So I can see that this rugby ball, I'm done with it. So I'm going to delete this rugby ball, okay? And also delete it from here. And this Superman, I'm going to put the Superman inside. All right, so now I see that my model is not that big because my geometry is not that big. My animation can be big because it's 8 second. So I go to the animation. Animation is about 345 KB, which is also okay. But this texture is 548 KB, very large, like half MB. Okay, another texture which is 1.41 MB. This is so much. This is so much that if I use this 3D model, I may not be able to import other 3D models. What I'm going to do is I'm going to right click on this, okay, and reveal in Finder. So somewhere in the okay, we can click on here and go to the reveal in Finder. So what you're gonna do is you're gonna open the folder where the model is. So the model is small, and there's a texture. There are two textures. Okay, so what you should do is compress these textures before you can use it. So I use this tool called Crushy. I've told this about in other tutorials. You can download it. Crushy. It's called Crushy. Crush E. Okay, so I'm just gonna import these two guys in here. This and this. If I import them here and then just crush them, okay, so you'll realize that how much memory it saves for me. It's gonna be quite a lot, like let's say 70%, like 65%. So earlier I was having it like maybe 7 MBs. Now this is like 65% smaller. So I'm gonna save it, remove it, and I'm gonna call them back and crush again. I don't want that big also. Like I think it's further can be reduced. Then I'll do that. So 300 KB was saved more. Also, like I sometimes feel that these textures with the model, they're more than 1024 cross 1024 resolution. So it just waste of space. So what I can do is I can force this to be at 1024 cross 1024. It is because I know that because this is 1.3 MB, so it has to be like either very big resolution because it's holding a lot of information. So if I now do that, it's going to be drastically small, I think. More 1.5 relieved now. So now it's a good size. In total, both the textures are about 500 kb. So I'm going to save them, remove from here, and go back to my project. Since I did this inside the same folder where everything was, now they're pretty smaller. Both the, like if you refresh it or something, that will reflect in here. Yeah, or to be sure, I think that's just it's gonna reflect in a while because now total project site has been reduced. So this is what I do to manage space. You have to actually learn to deal with it because let's say your client requirements are like this, that you have textures and you have to manage somehow. So like try to figure out ways how to compress those textures and try to fit in. I tell you, there are some projects I have finished at 3.99 MB, and it's like 4 MB is the limit. So 3.99 was the, like, I cracked it there because there were so many assets, and I had to do is like manage them somehow, like either reduce the geometry somehow, go to the blender and do those things. So yeah, we gotta figure those out. These are some things that will be there, like, because we have to compress everything. So try to follow standard methods like compressing the textures and everything. Things mostly will fall in place. Else you might have to sometimes tweak the project or something. I hope that answers your question, Kunal. Okay. All right. If no further questions, we can start with the session. Okay. I think try to also add some logics, add some creativity aspect to your filter. Like if you just have to complete the assignment where there are 3D models, and then there are some animations, of course. So how can you also like make them interact on the screen tab, maybe do some other animation, or um, just make them go away on something. Try to use those logics. Try to imagine it, like how would it be as a life of a super those fantasy um, you have imported like models and creatures. So try to figure that out. Maybe you'll end up making something really nice, and I'll love to try them as well. Okay, so this was done. Let's start with the expectation today. Like, what is the hand tracker, and what does it do? What happens? So this is our expectation from today. Like, this is probably very easy though, but this is what achieve. So if I put my one hand out there, there's a cloud on my hand, and I see that this cloud is I can squeeze it, I can control kind of size of it. Okay, but it doesn't rotate, but I can control the size of it. And if I have other hand, no matter it is closed or open, it detects the hand, and there's a rainbow connecting both the clouds. So looks super nice. If I stretch my hands, the rainbow is bigger. If I go up, it's kind of controlling the angle of the rainbow as well. So couple of things here happening. First of all, the hand tracker is detecting the hands, the motion of the hands. Um, and then there's a cloud which is probably bound to the position of this hand, and there's another cloud which is also bound to the position of this hand. So when I say bound to the hand, is probably child of these trackers, or let's say children, or the position are probably given to them. So there are two ways to do this. Actually, hand tracking, you can not, if you choose, you don't have to use a hand tracker, or you can also use a hand tracker. But there's a difference. If you use a hand tracker, you can only track one hand. But using the other method, which is the second method, you can use both the hands. You can track both the hands. So we're gonna start with it. I hope you're excited about this. It's pretty simple though, but there are a couple of things which are pretty tricky in this one. So Okay, so I'm gonna open a new project. Uh, Hey Devansh, you can add animation in Spark. Yeah, everything we do, animation is a very subjective word, but are you talking about the baked animation? Yes, we can. That comes with the model. Like you can also use Mixamo. Actually, it's a very wide question. You have to narrow it down for me. You can, of course, the answer is yes to your question. Even if we do animation in here, so whatever we do in Spark is animation only. If we move a texture from one place to another place is an animation. If you're changing something size is animation. If you're talking about the 3D objects especially, then 3D objects, if you have joints, if you know the like vertices and the meshes and the positions, you can create a custom animation, of course. But you have a baked animation. Baked animation are the animation which are done in, let's say, Blender or Cinema 4D, and you have created that baked animation that will deform the mesh, like let's say it's a dinosaur, it's make it will walk or like that. So those data is actually exported as an animation and is imported into Spark so that those 3D objects can also be animated. Doctor Strange magic hands. Yeah, I think those are animation sequences. So those animation are actually created outside Spark, and then you can import it as an PNG sequence, like a GIF, which is like a combination of multiple images. They run on a frame rate, so you can import that as well. Um, you can also create custom shaders in Spark. So, what if it's a 3D object and doesn't have animation skeleton? Good question. So let's do that. Um, let's try to import a man or a woman. This is where vlogger writes. Let's go with a woman here. Let's try to find a lady. I'm gonna find a low poly lady, so it's not too much to. It's geometry is too much. Like it's okay, but it's too much for me. Like right now, I don't want it. I'm gonna go something lower. It says 38,000. What is wrong with your 60,000? Mm-hmm. Okay, so what we're gonna do is we're gonna type low poly lady. Wow. Okay, there are a couple of results in here. Wow, 12,000 geometry looks okay. A little bit exposing, but it's okay. Okay, 19,000. So let's try this one. No problems. I'm pretty sure this doesn't have an animation, but like. Okay, so we have this lady. It doesn't have an animation, so let's try to work with this one. Okay, so what I'm gonna do is I'm gonna create an null object and just 3D models. It's a good practice that you always name your null objects and everything. So when you work on a larger project, it just becomes super handy to go through like items very easily. So this lady is now part of our project, and it seems quite big. So we're gonna make her a little smaller, like point 0.3, point 0.3, and point 0.3. And now she's part of the scene anyway. Any which ways, I don't want to use her on the front camera as my plane tracker inside the plane tracker. So it's better that we put her there. Okay, so a little bit on the surface. Your legs should be on the surface when we try to play with you. All right, so now this doesn't have an animation, and what do we do? We've got an assignment to do, and uh, let's check. So it's part of the scene understanding. Like we check, like, do we have a skeleton? Like, let's say it doesn't have an animation, but does it have a skeleton? So I go in here and I see that, okay, this body, this object, which is entire object, and there's eyes, and then there's just eyes. So this doesn't have any skeleton. So what do I modify? How do I add animation to this? So it's a very, very good question. Thanks for bringing it up. So what you have to do is you have to create the skeleton into some other tool. You have to take this model out of here, do some operations onto it, and then bring it back once you have the skeletons. So to do that, of course, we can't do it here. So we have to go to the project where it's located. It's located in my whatever it opens. This is my model, this GLTF. So the thing is, we use a tool called mixamo.com. I also talked about this earlier. Like mixamo.com is a good, it's by Adobe, so it's a very trusted, creates nice animations and also nice skeleton, and it's very easy to use. Okay, so but the tricky part is that you can only use FBX. You can't use a GLTF or like that. So first you need to convert it to an FBX. Okay, so we're gonna go a couple of steps. I'll give you some time to answer this last question, and we're gonna start with the hand tracker after that. So, so first I need to convert this model to an FBX because it's a GLTF, and I don't want GLTF because this doesn't support GLTF. I have to upload a new character in here. Okay, so first get the model ready. I'm gonna open Blender. Blender is an open source tool. You can use it for creating 3D models, animations, a lot of other things. It's easy to use. There are plenty of tutorials if you wanna like learn it. I'm not saying that become a pro or something, but in today's time, your knowledge is has to be need to know basis. Most of the time. So right now, if you're learning Spark, and if you have to go out of the Spark to do some work, you don't have to learn the tool entirely. You don't have to become a pro on it. You just have to know the need to know basis things. So right now, my objective of using this tool is to convert a file to FBX, and that shouldn't be hard. Okay, that shouldn't be hard. So similarly, if you have a particular task that you want to implement, all you have to do is go to the YouTube and how to do that. I'm pretty sure you'll find a 5 to 8 minute tutorial, and that will explain you how to step by step. So just like I'm gonna do this for this one. So I don't need this cube by default. It just I don't need the lights as well. So I'm gonna delete everything from the general project that opens for the first time. Then I'm going to import that 3D object that we were discussing with. So this is the 3D object that we want to import. So I can just go to File, Import. I want to import a GLTF because that's GLTF file. So this is the file that I want to import. So just going to click on it and import. So that file is here now. Now we've got our 3D file in here. You can do certain modifications, whatever you want to do with it. But my main problem right now is that it's not properly skeletoned, or like you just have like a one body or eyes like that. So what I'm going to do is I'm just going to export it. I just imported it. I'm going to export it to an FBX file. Let's say I'm going to go save into my downloads, or yeah, and I'm going to call it lady dot. We'll just call lady, and FBX will be added automatically. So now I have an FBX. I can check it out into my downloads folder. I have a lady in FBX, which is about a bigger size than what we had earlier. But now we're ready for our mixamo.com. So this is how it opens when you open it for the first time. You have to probably log in using your account, and then you have to upload a character. So click on the upload character, and it's gonna say that you can drag or select a character, whatever you want. So I'm gonna select this lady. When you select it, it's just gonna upload, and you'll be able to see the character. Just a moment. Okay, we see that a lady is right here. How we had a she already had a T pose, so that's why we are having it like a. And you can check how's everything like, kind of if the model is imported correctly or like there's no problems in that. So we can just go and next, and now it gives you an options like where is the chin. This says that teach me how do I know where are my wrists, where are my chin, where are my elbows, where's my knees, and where my so groin. So we have to just mark those markings. So I'm just selecting this and I'm gonna go that this is my chin. Okay, you can see a zoom preview in there. So this is my chin, this is my left wrist. Okay, this is my left wrist in here. So of course, so that I can have those finger bones or my hand bones, so that if this has to be rotated, and since we are using a symmetry, so wherever you put it, it's gonna just symmetrically put it on the other side. For the elbows as well, I think this is the elbow. Okay, this could be the elbow, and maybe a little down in here. And where are the knees? There are the knees, and this is the groin area. So I have set all those things. Now it's gonna do that calculation. Okay, so automatically that tool. So just do the auto rigging. This process is called rigging. When you assign some bones to a 3D model, it's called rigging. So right now that's what we're doing. So meanwhile it's processing. What did we do is what we just go to their files folder where the model was downloaded model was there. If would had it been a fbx file, I could have directly imported it here, but it was not an fbx file, it was gltf file. So that first I come converted to an fpx, and once that was ready, I just brought it here. um, Press next to confirm auto rigging character, then apply animations and stuff. All right, so why can't I see the model? Where's the model? For some reason I can't see it, so I'm just going to click on next. What? Well, sometimes it fails because of the online tool, I guess. I'm just gonna follow the same process that I did, and it should be elbows, should be the knees, and should be the groin area. And you can, also do this to like dinosaurs. You import a dinosaur. You can import a dinosaur, or like give them like bones, like where the wrists are and where everything are, and then make them dance on dancing moves, make them walk like a human. It's pretty funny though. Like use this kind of. I used to have a lot of fun on this tool earlier. I had Tom and Jerry models. Those were like my favorite because you can make them walk. You can make them do a lot of things. I don't see the character anywhere. Okay, probably there's something wrong with this model. So now you know the steps, and I think you can you can do those steps. What is wrong with these models? Okay, so let's try very quickly with this model, so you don't have a problem in here. So we have to do the same thing again with this model again. Um, right now, right. So I'm gonna import another one, which is this one. So to import it, we have to go and import GLTF, and then I can drag it in here and import it. It's the same model. We can also try to do this with the Superman. So go to import GLTF and this one the same. Hopefully. All right, we can also do this. So let me stop sharing the screen for a while and find a 3D model for you. Meanwhile, if you have any questions, bring it on in this process. Like you understand Mixamo, or you can try opening a Mixamo, and if you have a 3D model, try to follow the steps. And then once my model is ready, we can just try put on some elements on them. Okay, roller coaster. I think I am ready with the model. Doctor Strange Hands effect is actually made by me. All right, congratulations. They're layered planes with Z axis offset and some rotation saves a lot of file space. Yeah, that's a brilliant way to do it. If you can make all the animation Spark, that's my favorite thing to do. Anything which needs to be created outside Spark, then it needs a different effort. But if you're a designer, if you can create it, well and good. But if you're a designer anyway or a creator anyway, you can also do it in Spark. I can't see if my screen is shared yet. I'm not sure why. While uploading a character on XMAO, textures are not visible. Yeah, you can't. Textures are not visible then. Just the just the 3D model. So you have to reapply those textures into Spark again, like because you have the UV maps and everything. So nothing changes. It's just you get the animation. Okay, my screen is visible now. So now I'm gonna just take this new character that I have. It's now this is for sure gonna work because I've used this earlier in a couple of places. So this is just a normal human, very low poly. I think about 52 KB is the size of this, and which is taking time to upload. I got a Spider-Man 3D model, and there was no texture when I uploaded to Xamo. Yeah, you don't find textures with the model. Zoom out a little to see the model. Okay. Where can I find FBX lady texture to compress? Just go to the folder, I think. Like just wherever this find the folder, reveal in the finder, and then you'll find the textures right there. Like that. And if you have FBX, then the textures are not separately given there. So if you have like this, so I think you can delete it from here. But first make sure you have a copy of it. Then you can delete it and then compress it outside and import a new texture and assign it to your material like that. Can be done. How on earth are you not working? Okay, I'm gonna go to the Tom and Jerry again and import this guy. Those models are not working for some reason, probably some sort of geometry issue. Like this one is, I am pretty sure that maybe too less of a geometry, I guess. Oh, now it's working. All right. Okay, so this is like a very low poly man human human FBX. We could just give the chin in here, wrists in here, and the elbows in here, and the knees in here, the groin in here. So we go next. Also, if you have such queries, so now come back to it. I'll come back to that again. So now this is just like a looking here and there animation. So you see that there was nothing in the model, but now it sort of has been rigged. So let's go and see that, see how it looks. And now we can, apply some animations to this guy. Like if I want to say that, okay, do this jumping down animation. So this is model is going to do this jumping down animation, and like it's literally jumping down. So we could also do some like, um, I don't know, jog in circle. So it's gonna jog in circle, and then you can see the hands moving, you can see the fingers moving. In fact, so this is like a super nice. So it has become like that. So now we can download this. Okay, we can download this animation. It will give you an FBX file with. We don't want this skin, so we're just gonna go without skin, or you can go with skin also. Surprisingly for me, I think the material properties are still there, the colors, but I'm not sure the textures. They should not be. I think textures should not be um, working with it. So I just download it after applying the animation, and once you apply the animation, then now I have this FPX in here. Let's check the size of this. Right now it's 624 KB, which is a very good file size, including the animation. I mean, I can have like 4 such models and work with them, and I can also reduce it further if I go to the Blender or try to make it less poly. But it's already less poly. The size is bigger because of the animation. So now I'm just gonna import it, download jog in circle, and just put it right there. And I can see that's now it has like a skeleton. You can see all the bones. You can access those bones. Now you can see this skeleton is automatically added by Mixamo, and you can access any sort of bones and try to work with that bone, and make it like whatever animation you want to make it with. But you want to use the animation which is given by the Mixamo, that you can also use. What you have to do is playback animation playback controller, go to the animation clip, that mixamo.com clip, and this has to be assigned this controller to be the playback. And then you can see that in Spark it's moving around and around and around. Pretty simple steps. It just that was, I also like, yeah, you could have, if you try it, it's just like a 5-10 minutes job, but the need to know basis thing, and then you're able to do it. I hope, vlogger Rai, that has answered your question. And All right, we're gonna move ahead now. So, do we have any other projects open? No. All right, I'm gonna open a blank project and let's talk about the hand tracker. All right, so hand tracker, as the name suggests, like tracking of of a hand. So if I put out my camera, if I hold up my hand, then it should be detected as a hand, not just a shape. Like maybe like it has to be in hand. So like it's not just another shape because it is detecting that it has some fingers, it got the shape of hand, so it is detecting as a hand, just like a face. Like we do face tracker. So when we do face tracker, we see that that's these arrows comes wherever my face goes, and then that there's like a coordinate system comes in here. So all the coordinates, all the position of each and every element with respect to my face tracker is always zero because this is moving all together. Okay. So similarly you have hand tracker. You can invite the hand tracker, and then hand tracker, wherever the hand is, there's gonna be like it's gonna follow that movement, it's gonna follow that scale and the rotation as well. So let's talk about this hand tracker. When you click on the hand tracker, when you import it, it's already working. You can see. Let's go to the properties. If you want to put it in like some sort of layering system, I usually don't work with layer, but if you're like, let's say if you used to work with layers, you're familiar with working with layers, so you can try to give it a layer based on your rendering order, and those will follow. This is the visibility of it. So if it is not visible, like it's still gonna track, but if it is not visible, then all the children of this hand tracker would not be visible as well. The position, scale, and rotation, you can't change them because your hand is the position of this tracker, and the size of the hand is also the scale of this. Um, it is also the rotation as well. Is actually rotation doesn't work though, but that also we can't change in here. So let's try to talk about these two ways that we were discussing earlier. And also, like if I have two hands, it's just gonna only react to one. Okay, just this one reaction. What if I have another hand tracker? If you have another hand tracker, it doesn't matter. It's just gonna only track one hand. Okay, just like if you take this out, then this one. If you take this out, then this one. So it's just gonna track just one hand, right? Like yeah. So um, I'm just gonna drag it inside and delete the other one because we'll talk about that. So what is the setup here? There's a hand finder. This is the one who's finding the hand. And then now we're selecting like which hand are we talking about, and there's this hand tracker. So if I have another hand tracker, this doesn't work. So this is something which is we're gonna use only when we just have one hand tracker to be used. But if I want two hands, then this method is not gonna work. This method is not just suitable for us. So what is that method which can do that? So I'm gonna just delete it. Like we don't need it. Okay, let's try to add something to it. Like how does this work? So I'm going to add that ball to this that we recently imported. This rugby ball is gonna be here in any minute. So this hand select is a patch, takes input as a hand. Like okay, hand finder found some hands, then it's gonna give to hand select, and you can select like okay hand number 0 or hand number 1. So like two hands. So this rugby ball is the hand tracker. So whenever there's a hand, the rugby ball is gonna come on the hand, right? So I can like if I go back, the scale is getting smaller. If I come, so it's getting bigger. So this is the work of the hand tracker, and this is as simple as this. If you have two hands, it's not gonna be working like this. So if you want to switch, then you probably have to like either put it in front or it's like put it in the back. So like this. Okay. So this is the one way to do it. It was tracking because it was child of the hand tracker. All right. So this we're done with it. Now we're gonna use another method here that the hand you find What I'm going to do, I'm going to use a bounding box. So let's talk about a bounding box. Let me see if I have the battery today. So, okay, we do have battery today. All right, so I'm going to share my screen to you guys. Okay, so for example, consider this is your very bad at drawing, so bear with me, okay? So this is my, let's say, hand, okay? Wow, super bad. So this is my hand, and when I'm talking about a bounding box, what I'm doing, I'm saying that the bounding box is just a rectangle, okay? It's just a rectangle. So this is a bounding box. So what I'm going to do is I'm going to put this bounding box that it covers all the areas of this hand. So my bounding box should cover the maximum minimum x and the maximum x, and also cover this minimum maximum x like the y. So my rectangle would become like this. It's covering everything. Okay, is like until my hand is okay. So this is my bounding box. This rectangle is my bounding box. So this bounding box gives you five coordinates actually. This is number one. We call it like top left. This is top right. This is bottom left, and this is bottom right. And there also going to be one more coordinate, which is center. And I will also know the height of this, and I also know the width of this. So if I know all of these things, if I know these things, I have this parameter, I have this coordinate, I have this coordinate, I have this coordinate, and this coordinate, and this coordinate, and also this. So 1 2 3 4 5 6 7, these seven parameters can make me help to like place an object. Let's say where do you want to place the object? Do you want to place the object in here? Do you want to place the object in here, in here, in here, or maybe in the middle of the hand, or maybe just the center of the hand? So it's just going to help me decide that. So that's the method. This is a 2D. These are 2D coordinates, and because of these are 2D coordinates, we are able to track two hands because it is very much calculation expensive. So that is why hand tracker was not able to do it, but this will be able to do it. I hope this is clear. Okay, so now we understand what is a bounding box. Let's try to work with it. So a bounding box will be, um, we're going to call hand bounding box. So we selected a hand. We talked to the hand finder. Hey, can you find a hand for us? It says, okay, I found some hands. Which one are you talking about? I said like, okay, hand number 0, and then I said like, okay, let's go to the bounding box and get those five coordinates and two values like the width and the height. So for that, or also gives like, is that hand tracked? So I'm just gonna take this value as like a boolean. So whenever I'll have this hand up, it will be like, okay, true. Like, okay, I found a hand, which is number 0. So what if I had a hand select number 2, which is like index number 1, 0 and 1, and then you do the same thing in here as well. So this is going to detect the index number 1. So that will be my hand number 2. So right, this is my hand number 1, and this is my hand number 2. All right, now I have two hands detected in the scene. So okay, that's okay. Let's use those coordinates now. So what I'm going to do now is click on this bounding box. It gives me some vectors. Okay, so go to the bounding box unpack. There's this patch called bounding box 2D unpack. So kind of unpacks the 2D positions of those coordinates. So if you unpack it, you'll see now you have the top left coordinate of it. Okay, like right now now I have a hand, and so you'll have this top coordinate of this, you'll have the top right coordinate, you'll have the bottom left and the bottom right, center, width and height, all the parameters that we talked about, like how we're putting that rectangle over the hand. Going to delete this hand tracker because we're not using this anymore, because our hands are actually detected by the bounding box. You can see this, we don't have a hand tracker anymore. Instead of the hand tracker, we have the bounding box. This is where the hand tracker was earlier. We removed that, and we had like, okay, we'll take two bounding box. We'll imagine these two hands as two rectangles, and we'll try to work with those rectangles, those positions. Okay. So very interesting technique, by the way. This technique can give you a lot of functionalities, like I remember I made a golf game, and then the golf game used the same technique. Like we kind of choose the bounding box and coordinates of the rectangle, and then try to place things accordingly. So when you play with a ball, golf ball, it has to like go in a curve motion. So that's where it is very helpful to determine that 2D position and how it's going to look, determine the scale of it. Okay, it's interesting anyway. So let's learn this. So let's have two rectangles in our scene, rectangle number one, rectangle number two. I'm going to call this as H1. So H1 is a visa everybody wants to US. And this is H2, okay? H2 is also a visa, by the way. So H1 and H2, these are two rectangles, and let's give them like a different material. This is matte H1, and I'm just going to duplicate this guy, and this H1 is my mat1 and H2 is my mat2. Okay, gonna select both of these. If you select two material together, you can change the common properties like flat, and then now the number one is color number this, and number two is color number, which is a little vibrant, not in nature. Okay. So now I have two rectangles. H2 is visible because of its order is like, because it's in front. So it's rendering first, and then there's the blue rectangle as well. So right now they have like a fixed 100 by 100 width. Okay. So I'm going to take this H1 and its width and height, so that this can be the height of the rectangle of the size of my hand. Okay. So I can show you like where was the midpoint, where was the left point, was the right point. So I'm going to take this width. I'm also going to take the height. So width, I'm going to take it from here. Height, I'm going to take it from here. And then my hand one comes. You'll see that I am controlling the size of that, like the width of that rectangle. Like, as you can see, right? This is controlling the height and the width of this first H1. All right, based on the position of my hand. And similarly, I could also do this with the hand number two. So if I go to hand number two, use this bounding box in here, and do this H2 as width and height, and I can use that as a, like the size of the hand would be the size of this rectangles. And then right now the position of both the rectangles is same because it starts at 0, 0 by default. So the position we can also change. I go to the H1, click on the position, and the position is now, if this is my top left corner, so this is going to be the, if I pass this position, then this is going to be the 0, 0 for my rectangle. So if I connect it to the top left, then you'll see that this is actually tracking my hand, and if my hand is bigger, smaller, it's changing with that. All right, I'm gonna make it a little opaque, actually both of them, so that we can see our hand as well. Okay, so now you see that this is the current position. Okay, the 0, 0 of the rectangle started from the top corner, top left corner, and if I do this to the top right, it's gonna shift. It's gonna shift in here. So this is my top right corner, and everything is after that. Like, so this is 0 0 comma 0 0 for my rectangle. If I do this to bottom left, it's gonna just come down to this left and it's gonna come down. If I do the bottom right, it's gonna shift in the right and the bottom. Okay, so this is how it's tracking. So, and if you do it the center, then this 0 0 comma is gonna start from the center. All right, yeah, center, the corner of the center. Is there any question in this? Do we understand this? I'm quickly going to do that for H2. Are there any question related to hand tracking at the moment? Let me know. So if you do this for this left and also for the left, this is going to exactly track the position of my hand, and I can like do a couple of things with it. Does hand tracking provides 3D joints, positions, and rotations? What do you mean by 3D joints and positions? Are you talking about the wrist joint? Or are you talking about the finger joints? Irfan, we actually can't use them like the way you're saying. The joints are not provided. Shaker, were you not attending the classes? How you can do is you can use a slider UI, okay, and this start from the zero and it goes start from the zero and goes from the one. So we want to control the opacity of it. So let's say this is the material, and so its opacity has to be controlled. So we bring out the texture because opacity doesn't have a consumer patch. So what we need to do is we have to give this color. Okay, so I have to have a value, and this value is to be a color, and this color has to be picked like this. So I'm using the same color, that's why I'm just doing this. You can choose any color. Okay, so this color is to be my texture, but I need to control the opacity. So I will mix this guy. I will mix this. Okay, so mix this as a number or as a color, doesn't matter. So maybe color would be better to visualize. So, or maybe number, doesn't actually matter. So I have to show the opacity, right? So initially depends, like, so if it is zero, that means 100% of whatever the first input is. All right. So now I have to swizzle it and say XYZ 0. And then this is my transparency. So this is my opaque and this is fully transparent from 1 to 0. This is the alpha which is going to adjust this. So if I connect this value in here and this make it visible, the way you slide it, you're going to control the opacity of that. Just give this to this texture. So this is H2 and H2 is red. So you can see that if I increase this value a little bit, you can see the opacity changing. All right. Okay. Okay, Irfan. Opacity does have consumer patch. Where is that? Please also tell me where is. No, we don't have opacity consumer patch because it's not there. Is it there in the newer version? I don't think so. Opacity doesn't have a consumer patch. Uh, Irfan, finger joints. No, finger joints are yet not been segmented yet. So this is a this is a machine learning capability that's happening right now, and implementing it for fingers is pretty complex, very complex thing. So it has not been done yet. So you will you will have it, I think, sooner than later. I guess sometime. Yeah. Okay. Okay, Rai. Now you know. Now you know. I can't wait. Would you make of those? All questions done. All right. It's okay, Shekhar. Yeah. Opacity. We were just changing it for fun. Right now we have. Okay. Now we want to do is we want to have a texture. We want to have a texture to in the between, texture in the between of these two hands. So let's try to find that rainbow so I don't have to like create some things. So I'm gonna just take out textures from that project so that we can work with it. Go to the welcome screen, open this guy, open this guy, and take this texture to another project. Now I know. Okay, cool. Now I can delete this. So we just wanted those textures so that it looks better. The first one is H1, M1. So I'm just gonna give this texture to like hand one, and you can see that because of the opacity, that's not visible, and because of the given color on the top of that, so hence this color is different. The original color is supposed to be like this, but because of the material is like that, so it's changed. But we can make it white, and it's will be the original color of it. Okay, number two is matte 2, and I'm gonna give this texture replace me 2, and then the opacity is again, and okay, replace me 1. Okay, so now I have two hands. The second one is not really great looking. Similar, I'm gonna change it to, let's say, yellow. Okay, so you see that sometimes this is my right hand, and my right hand is has green, and now it doesn't have green. Now it has green. So it depends like who is coming first into the picture, and then who is hand 0 and who has hand 1. So this also we will check to work with. So these hands are tracking. We were done with the part. Now we would need to do, we need to add a rainbow to in the middle of these two. So okay, so this is all right. What we not need to do is take the center position of hand 1, so, and the center position of hand 2. So what I want to do is I want to place the rainbow in the middle. So probably I need another rectangle, and we'll call it rainbow. Okay, I'll also give it a material called create material, and this is my flat, and place me. So right now it's resting above, but we'll work with it. I'm just quickly gonna change the um, sender, and this is my sender. So this is hand 0 right now, and 0 center. So this is a 2D position, I think. Yeah. So we're gonna create a 2D vector, although it doesn't matter, but still try to see those values. Try to create the variables as they should be, so that we don't get confused when the project is like a bigger than this. Okay, we need a receiver. What we need is a copy of it, and this is hand 1 center. All right, so okay, now what should be the position of this rainbow? I think the rainbow should be in the like a middle center of these hands. So let's say if two clouds there, so the leftmost point of the rainbow should be the center of my hand, and the rightmost point of the other rainbow should be the center of this hand. So seems quite simple enough to me. If I take the center of this, and if I take the center of this, and if I add them and divide by 2, would I get the center of in the middle? I think this is how it's gonna be. So if I directly divide that, so what I'm going to do is I'm going to add these two enter positions and divide by 2 as well, so that I get the average of those both the hands. And if that can be position of my rainbow, that would be really great. Okay, it's kind of it works, but I don't know the scale. What is the what is the scale of that? So to get the scale, I think we need a bounding box in the x. How do we get the scale of it? If I subtract if I subtract the x of this to the x of this, should get it the way. Okay, so let's see what we have. We have top left, and I want to know the scale. So scale has to be same for the x and y, and how much distance is between them. So scale is only going to depend on the x of that. So let's say if I unpack this vector 2, and I also unpack this vector 2, and I subtract this from this, and this should give me the exact difference between them. All right, so if I pack this back, and that spec could be vector 2, and this should be the okay, I think that should not working. This should not work. We need a it's becoming too big. Okay, not the right way, because we got divided. It's a bigger coordinate, so not this way, not this way as well. So we need to modify the width and the height. So the width and the height of these two. Okay, so the width would be, so that should be the width. Whatever we did just now, that should give me the width of that. So delete, get the width from here. Yep, getting the width, and also the height. So height doesn't need to be subtracted, I guess, but we don't need this value. We need this value. So scale in x is okay. Scale in x is okay. So I don't really think we need to subtract for the y. Yeah, so now the scale is okay, but the position is not quite accurate. So we will make that accurate. I just want to try this though. Okay, so can we use emitter or 3D objects instead of texture? The logic remains the same. Interesting question. Actually, no. If you use a 3D object, so try to see that the way we are placing these objects as a 2D object. Okay. So I'm actually going to take an example to answer that question. Um, that example. So what we're gonna do for that example, we will we will take the face texture, like face texture, which is like a 3D mesh, and we'll put that on the hand. Okay, so we'll do that. So for that, give me a moment. Uh, so for that we need a face tracker, I think, but face tracker will go back to you. Um, we got the X, okay, but I see that when they're very closer, it's not very like within far, and if there's only one hand, I'm still getting I'm still getting a width because the hand is not detected, and this that one is always zero. It's gonna give me something. That means I can't use this. This method is not good. This is not good because it's still giving me values when my those second hand is not here. So again, this could be a method to do that, I think, but not suitable in our case right now. So ultimately, when we were subtracting values from this end to this end, trying to figure out how far from each other they are, so we were using X. But if you use a distance patch, the vector to distance patch, and if you use this like this, and if that becomes my no, that will give me, yeah, that will give me a number. So it's similar output than what we had earlier because we're having it in Y, but we also want that to be a height. Same thing, I think. Yep, works exactly right. But if I want to shift it a bit inside this towards this, then probably add something. No, if we add something, then it's going to add to the distance. So we're going to do is try adding something. Is the little offset from where we want it. We want the center of this. So probably this is like a how we make the texture. So if I add something to this, let's say this works quite in the center, but when this comes, now this is shifting. Okay, we'll get back to it. I think X and Y. So we're doing this wrong. We're doing this wrong. We don't want to do that. To okay, once we are when we are using this tense, then our values have been reduced now. So we can use the scale because earlier we were having like 300, 400 values of like difference between two hands. That was like too much. But we use the distance patch, which is gonna give us the distance like a diagonal distance to them, so which is much better. It's again too much, man. Studio scale, right? Then studio scale has to be. This project is buggy or something. I think. Okay, so I think we gotta change these to something else because should be working now. So I'm gonna go by default 100 and 100. Okay, now it started coming closer. 10 and 10 now it started coming closer. So what's happening with that? Because the value of the scale, the difference between this position is in 2D coordinates. And if I give that to scale, that's going to create a very large value. So you can see that how large is that become. So it is working, but it is working in a very larger perspective. So we need to like scale it down and scale it down so much that it just exists. So probably to exist, we can put it to one, and then now it's perfect, right? Like we don't need much bigger, and you can control it by giving it to, like, let's say 5 now. It's quite big, so for me, like, the one was okay and one was okay. This is the one way, and another way was to, like, probably uh, we would have to divide this difference by the size of that, so that could have given us that right scale. But if we take one, that means we'll take in just one unit, so one and the same thing. Now what doesn't work is the it's not turning the way I'm handling the turns. So we need to calculate, I think, angle between them. So let's do that. I'm going to look up some questions if we have. Thanks, Jessica. Emitter in 3D objects, I'm going to come back to. First, let's calculate that angle, and if we have enough time, we'll do that. You can big the rainbow in the head. After that, look will be sky like rainbow with the cloud. Sure, why not? You can do that. I mean, that's your homework. I guess we can use distance on the scale for the rainbow. Yeah, we could do that. The problem was actually the width and the height of the rectangle. We just have to take one unit, and then we could, if we take one unit, that means we're taking each pixel as like one. Like, if this is one, then this is 375. So we took like just one, so that it fits our exact as the coordinate value. All right. So rainbow must appear only when both hands present, and never we calculate angle between each hands to rotate. Okay, we are there at fun. You're ahead of us. All right, so now we have our. I think we have almost everything. We have got the textures, we have got the rainbow, and we got the scale correct. We need to see the angle between them. So how to create the angle? So there are two things for it. The first, we need to see that which hand is the left hand and which is the right hand, right, if you're calculating the angle. So first we need to know, like, this, if this green comes on the right, or if this comes on the left. So we need to know that. So to know that, I think the easier way to first calculate the, like, which is the left and which is the right, and how can I know that which is the left, which is the right? So if what I have is hand number 0 and hand number 1, now whichever hand comes first becomes my hand number 0, and the comes second becomes my hand number 1. Okay, if this happens, then this is my hand 0 and this is 1. However, they are not left and right. So to know that which is left and which is right, simple method. Okay, if this hand is here and this is here, if I calculate the x of this is greater than x of this, then this is going to be my right hand. Like, this is going to be right hand because this is greater, okay, and this is lesser, so it is in the left. Now there is a case where I put my hands like this. So yeah, of course that's the case. But if I also put a condition for that, then I can also manage it. Like, in, let's say, yeah, if somebody comes like this, it's going to treat it like opposite of that. But most of the cases, this is how it's going to work. So let's do that. So from how I'm determining my hand center of the hand, I'm just going to subtract the x of this to the x of this. So I have to unpack this. Once I unpack into vector 2, I'll I'll take that number, and I'm also going to do this to my second one, which is going to do for the this one. So if this subtraction is greater than 0, would be the positive. So then I'm going to say like if then else, if that is true, then give me the vector 2 value of the original hand. Thanks, Aman. Thanks. Thank you very much. Actually, subtracting it and then putting it greater than 0, wouldn't it be the same thing if I do this, like if I remove this and if I do this, it's the same thing, right? If you subtract and then compare if it's negative or positive, or you can direct compare like it is greater or not. Simple as that. So we don't need to subtract. We can just do this, and once you do this, then if that is the case, if this happened, then I'm going to consider this as a left hand. So if this happens, then my left hand would be the other one. So this is my position, and if this happens, then if not true, then this will be my position. So what I'm doing is just comparing the x values. If the hand 0 is greater, then I'm going to call the other hand as a left hand. Okay, if this is greater, then it's going to right hand. So this is my left hand. So I'm going to call that one left value. I given that to the then condition. We're going to make it a little neater. Don't worry about it, but just try to understand this how this happened. And if it is not, so this value is my left hand. I have determined that. Okay. Do we understand this? Is there any problem? Um, Okay. So this is my left hand, and if the if the other things happen like that, then I think I'm gonna just give it to the. This was the bottom, so this is gonna be the top, and this is going to be the bottom now. Okay, and the condition is the same again. So if this happens, then if this is happens like this is greater, x is greater than the left, then this is going to be my right hand, and this is left. If that doesn't happen, then just the opposite. So this value is going to be my right hand. So I'm gonna just give it a value right hand and a vector 2 again. Now I can see that these calculation actually so much confusing that I'm going to put it in a group, and I'm just calling it determine hand. Okay, determine the hand, and then you can see that these two values are coming out of it. So we can make it like a patch. Go to the group properties, input one. We can put one is my hand 0. Right now I'm putting it hand 0 because I don't know left or right. So hand 0 for me. This is hand 2. I don't know left or right because it's just an input. But when it goes to the output, I know that my top one is my left hand and my bottom one is my right hand. So now I have these values like this. Okay. So now this is clear. I have determined the hands. Now I need to find the angle between them, and to find the angle, it's a um, very simple thing. We use arc tangent. Arc tangent is like we actually calculate the, like, my hand is there, then the distance would be like this. So I know that the sine theta of that coordinate will give me the perpendicular, and the cos theta will give me the base. So the arc tangent is actually directly gonna give you the tan, the entire angle, like a. Okay, so simple math. I think all you have to do is first need to know the angle. So we need to know like which two coordinates are we talking about for the angle. Okay, so let's do that. So I'm going to take my left hand's position. So I'm gonna just like put them, delete them. I think don't need them. We have left and right already written here. So I'm gonna take this hand and I'm gonna subtract, because I'm calculating the distance. I'm gonna subtract both of these, and this is a vector 2, and then going to unpack the subtraction, like whatever the difference came between them, and take an arc tangent of it. Okay, so arc tangent is gonna give you that angle. So in the arc tangent, you give the y here and the x in here, and then you have the angle. Like this actually gives you the angle. So let's see what is that rotation. We go to rotation, and this is the 2D plane, XY plane. So whatever angle that we want to work with is the z angle. Okay, so I'm gonna pack it to a vector 3, and I'll see that this should be rotating a little bit. Like, I can see a bit of rotation, but it's just like I think it's maybe too small. Okay, this arc tangent gives you angle into the format of pi. So we need to like uh, first multiply it by 180, I think, to make it that. So we multiply it by 180, and then we have to divide by pi. Okay, so if you multiply by 180 and then see this value, you see that this is working, but it's working in the because it has pi with it, so we have to divide it with pi. So pi is 3.14. 3.14. We divide it with pi. Now you'll see that the angle is okay, but it just now it's working correctly. But first of all, we want these rainbow to go on the up. Okay, so to go on the up, that means if I add 90 degree to it. Okay, if I add, because I divided by pi, now I don't have, I'm talking degrees now. If I do this with 90, then this becomes like this. Okay, so I have to do another 90. If I add another 90, like 180, then it's gonna be okay. But it's just going into the opposite direction right now, so I'm gonna multiply it with um, -1, and then I'm gonna give it to here. So now it should be okay. Now I know the angle. Now I can use that angle to rotate my entire rectangle, which is the middle. So let's recap what we did. We subtracted the left hand and the right hand, because we knew like which hand is right and left. And after the subtraction, uh, we unpacked it. After the unpack, we did the arc tangent of y and x, and multiplied with 180. We actually multiplied by 180 divided by pi, so that the pi goes away and we have a degree values. Okay, and this is the degree value that we have, and we added 180 so that the thing was in the opposite direction, and they multiplied by -1, so it rotates into like the correct direction for us. Okay, so what you're gonna also do is that now I can see that if my one hand is there, I don't want this rainbow to be visible. So what I can do is both of these things are if both of these hands are tracked, then only show my rainbow, else don't show my rainbow. So now I can see the cloud, but both of the hands, then I can see the rainbow, right? This is a perfect way to do it. Wow, it works super nice. Just like like seems like it works on the 3D, like because of the scales and everything. So yeah, you can also put this into a patch, like because this was the angle calculation from here. This is the angle calculation, so angle we get here. So we can create a group for this also. Create like a angle calculations. That's it. We have reached to the end of our thing. Okay, I'm gonna address a question which was asked by vlogger Rai, and she wanted like, what if there's a 3D object? If there's a 3D object, I tell you like this rugby ball, and we take it inside the focal distance, and if I try to use the positions, on like the way we were using on the rectangle, this will just go away, no, because this is point 1, point 5. This moves in a different coordinate system. However, these rectangles and everything, they have like 0 to 300 here. So this is like a very different rectangular system, coordinate system. So we can't use those values like that directly. So there has to be a conversion. There has to be a conversion between before you can use that. So that conversion of 2D position to 3D position has to be done. Of course, you can use this position. We have to convert it first. So to convert it, I think all you have to do is divided by the screen size. Should give you the. So if I take this, let me take the device size first. So what is my screen size? My screen size is 750 1334, and divided by 2. This is my resolution. And if I now divide this position by this resolution, and then I'll have point values. Okay, I'll have, because now I'm dividing it. So if I now pack it and pack it to a vector 2, because this is giving me vector 2, and third z, it has to be 0. And if I do that, this should be tracking the ball somehow. It is tracking the ball, but not quite accurately. There are a couple of things that needs to be taken care. So of course we can directly do that. There has to be a proper calculation to do that. Like what is that 1 pixel? Like 1 pixel, like not pixel. Let me remove these. So what is this one from 0 to 375 in this coordinate system in the canvas? What is this one value can represent in the in the plane coordinate system, the other coordinate system? So how do I explain you to that? So let's go back to the drawing again and try to understand this. It's an important thing. I think a lot of filters, a lot of time you will have to like work into different coordinate systems. So this is my okay. Okay, so what I have in here is this is my phone. Okay, and when I talk about a canvas, that means this 2D screen space. Okay, which is at 0 comma 0 in here, and this is the maximum size of the coordinate, like maybe 375 comma 0, and this is 0 comma 667, and this is 375 comma 667. So these values are like, because these are 2D coordinates. But when a 3D element comes, like a 3D element comes in here, they travel differently. Okay, so for them, this entire screen is one. That means right now, if they're at 0 0, then this is going to be zero point 0.5, and this is going to be minus zero point 0.5 in x, of course, comma 0 and comma 0, like that. This also is also divided into 1. Okay, so this value has to be zero point 0.5, and this value has to be 0.5. That means a very simple mathematical calculation. If you want to relate these two, then you have to make a relation between this 375 and this 1. If if one unit if one unit represents 375, okay, or we can say that if 375 units represents this 1 unit, then how much of the one pixel, how much of the x pixel that we are talking about, like which pixel is going to be, is 1 about 1 by 375 into, like, where are we? So let's say we are at this distance. So what is this length? You can multiply it by that, and then you'll have the conversion. And similarly for this, we'll have to do 1 by 667 into, and this is a variable, like you can have this different, for different phone has different sizes, but you don't have to worry about it because you can just use the screen resolution patch for that. So this is what we have to do to make these calculations. There's one more thing. One more thing is that it starts from here, 0 comma 0, and this is the 0 comma 0 for this one. So we also need to make that adjustment, like, uh, if you can't directly rely on that. So this is the main difference between these two patches, these two coordinate systems. Okay, so to convert this, obviously this is not the correct way because we're not getting the exact values like we should. Uh, but I can tell you that what I need to do is I need to convert that. I need to first bring it to this 0 comma 0. Like this 0 comma 0 should be this 0 comma 0. So I need to shift it there first, and then I can think about it. So because right now it's, I know that it's not correct. Right now it's just it's tracking it, but it's tracking it other way, because I can see that if I'm going up, it's also coming down because of that calculation is not being. But in the x it is right, in the y it is opposite. I can multiply it. Multiply with -1 in the y, and that way it's going to track okay. uh, okay, we divided it by 2, and each pixel should give me that conversion. So 375, so we have to multiply it by 375. That should again be divided by 2, I guess, because the center. Yeah. This seems about right. Like right now it works, I know, but this is not the correct way. Maybe I'll probably create a patch for this and share in the next session, because see right now I can track it, but it's not the correct tracking. This is missing something, and then that calculation, what we are missing is that this difference of, this is 0 comma 0 for the plane, and this is up 0 comma 0 for the rectangle. So I need to adjust this first, and then we'll have the exact tracking. Right now we don't have the exact tracking, but I'm still able to uh, track it, okay? But somewhere in the lines of that, okay? So this was to answer vlogger Rai's question. You can still track it, right? There are a couple of adjustments that I need to do here, but I'll share them in the next session because there's this thing that I've calculated. Actually, it's a longer calculation that I have to do, and then that you can apply anywhere. So I'll share that patch with you. I made it for these conversions, and then you can convert your nose positions into the focal distance, and you can do all those things. It works similarly what we are doing in here, and the concept we just discussed in the drawing. That's the main concept that we work with. Okay, so I'm gonna delete this rugby ball, and we have very less time. So if you can come up with a question, please feel free. I'm gonna do just a little bit fun here. Instead of these clouds, I'm gonna put my own face. So very quickly, pay attention. Face tracker. I'm gonna have a face match, and I'm gonna use a little bit better method. Not just like I'm gonna use a render pipeline. So right now there's nothing in this render pipeline. What I want is I want this hand number one in this pipeline. So this hand number one should be a scene render pass, and this could be the scene object, and the scene object would be the, okay, don't want it to be black. Okay, so this H1 is only visible when, yeah. So I can see this, I can only see this cloud. I am moving my hand, but I can only see this cloud because this is the only thing that I'm rendering to my device. All right. So what I want here is my face. Can I do that? Let's try. So this face mesh should be having a material, and we're gonna call it flat matte face, and this matte face is should be given a texture. So there's this thing that you can't extract the face tracker extraction if you're using the render passes. So what you have to do is you have to use the face render extraction render pass. Okay, so this is a new patch for you, but I just wanted to introduce. So this is a what it gives you. It if you tell this, like everything is similar to this, okay, this scene render pass, but there are a couple of new options. Like it asks you which face are you tracking, so we say like face tracker number 0, and we like it, you need to give it the camera texture as well. So if you give the camera texture, it will show you the face trackers texture. So now I can really see just my face. Okay, so if I take this face mesh matte to the face mesh matte, then my face should be visible. All right. So see, our goal is this. This is our main line. Okay. So this is what we wanted to do. We gave this rectangle to just show this. Now we need to change this cloud to my face. So this cloud is given by this material, this material. Okay, and what I want to give it to this is my face mesh, and my face mesh is given to the face mesh. So I'm going to take this object out. I'm going to create a scene render pass. Okay, and this is going to be my scene object, and that's going to be my face. So I can see that my face should be like visible right now, and this should be working now. All I need to do is remove this to opacity to 0, and then I can see that that face is right on my hand. Okay, I can just move it to like left corner, then I won't see my hand. Like I can do that. If I don't want to see my hand, I can just this is the hand number 1, so I can just change this to possibly top right, and if I do that, then I won't see my hand when it's moving. Okay, but I see that there is a my teeth are not proper. Also my eyes are not proper. So what you need to do is disable the eyes and mouth because we're getting them from the camera texture. So now they're okay. Now if you go close to it, your face is bigger and the position is also changed the way you want it. All right, so this you can do with both hands. You can also just show the eyes on your hands, like you can show your eyes on your hands and like do things like that. But this is done using the custom render pipeline. So just gonna recap. I used three these patches and everything was done. Okay. Notice these structure. So this is the main goal that I wanted. So first I needed my face to have this texture. So I created that texture. Then I passed this texture to the material of this face mesh, and I separated that face mesh using the scene render pass and gave it to the material of that rectangle. So now that rectangle has the face texture. Do we understand this? Any questions? Let me know. Okay, this is crazy. Lots of new things. I didn't know I will need to watch this class again a few times. Okay, I'm glad. I think I will also share a few useful tricks, because if I start calculating right now, because I don't remember what I did last time. If I start calculating that now, I can also do that. The concept is same, that we have to shift this from center to that there, and then we can calculate that. But we're gonna do that probably in the next one, and we'll cover those things, how to actually change between how to transform between different coordinate systems. Okay. Um, how can we track our attendance, assignments we have submitted, and all? Attendance link. I want to show a room inside with some characters when opening the filter. You want to show a room inside, okay, and with some characters. When you open the filter, how can I place that room? Is it possible with the plane tracker, or is it any other way? Well, we open the filter, you want to see the characters. Doesn't seem like a plane tracker capability. But plane tracker does to you is that it puts things into the world, okay? So when you move your phone, when you move with your phone, you kind of move into that world environment. So you could also do this like in front camera without using a plane tracker. So like that doesn't matter, but probably I think what you want to do is use a plane tracker. First place the room in the plane tracker, then place your characters into there. When you open the filter, you have to first find the plane. So you tap and you find the plane. Once you find the plane, you can just walk into it, and maybe try and articulate your question better. You can use our Facebook group there. You can post questions, and either I can reply, just tag me, I will reply. Sometimes I miss them. So yeah, plane tracker is the way. Any other way is that it depends on what you want to do. So probably, yeah. Okay, thanks, Rai. I'm glad you asked really nice questions, and this is nice. Please be more open. Please ask questions. Such great questions today. It was an interesting session today. I really love it. That we talked about some complex stuff into detail, and then I really want you to get familiar with every of like these things. Okay. Can anyone let me know what is the assignment last date right now for you? Second, second submission, second assignment submission. What is the last date for you? 4th June, which is tomorrow. Okay. There's a good news. There's a good news. The timeline has been extended to 8th. Okay. So you have 4 more days now. But this is to, you use these 4 days to apply some things that you learned recently. Try to, try to make it like as good as possible. Just try to give it like those few extra hours. If you're complete with it, then try to optimize it. If you have not completed it, then good news for you. You can utilize that time and make something better, and gain that confidence as soon as you can. And I'm just going to remind you again for the competition that's happening. Spark AR, Lens List, two competition right now, thousands of dollars they are just distributing. But again, you have to make some good work. You if your work is recognized by a global audience, because this is a global competition, creators from all the countries they're submitting their work, and you can also, you are as good as them. Don't worry about anything, just start working on it, and it gives you that openness that you can select any idea that you want. Right now assignments are like a little confined because I want to make sure you learn, but for those competitions, those hackathons, you just feel free whatever you want to make, and then bring that money home. All right, that's good. I'm done for the today. Thank you so much, everyone.
Thank you, Naveen, and thank you for announcing the new date. So I'll just repeat what Naveen said. We have extended the last date for assignment 2 till 8th June. Please make sure you create your effects and submit them before 8th of June. Thank you and see you in the next session. Thank you, Naveen.
Thank you, Askar. Thank you, guys. Bye bye. Good night.
Bye.